So, axiomatic system. An axiomatic system begins with a small set of undefined terms and builds through the addition of definitions and postulates to the point where mathematical theorems can be proved. So theorems are something that can be proved. Postulates are made from undefined terms and definitions. There are three undefined terms in geometry. Anybody know what they are? The three undefined terms of geometry? Okay. Well, we call the terms undefined because when they first started geometry, Euclid, anybody heard of Euclid before? Okay, Euclid was a ancient Greek philosopher and mathematician, and he started geometry. And since there was nothing there for geometry, he had to come up with the terms to describe it. So he came up with the three undefined terms are point, line, and plane. And no one had ever defined a point before, or a plane, or a line. So he made those definitions from scratch. So they were undefined. All right, so that's what he started, and he built geometry off of those three definitions. He had like 28 postulates or something like that, and that's the basis for the geometry we study. We are studying Euclidean geometry, and so the postulates were ideas that he came up with that weren't proven. They were just the ideas he had about geometry, and we use those as the rules for how we study this subject. Now there are other kinds of geometry which use different rules. We'll get into some of those at the end of the course. You've got spherical geometry, or taxi cab geometry, some different types of geometry, and the rules that we use to do those type of geometry are different. So we are doing Euclidean geometry based on Euclid's undefined terms and postulates. So, as I said, the first undefined term is point. Okay, a point is the basic unit of geometry. It has no size, is infinitely small, and has only location. It's named with a capital letter. So we've got, here's your point. You name it with like the capital letter A. It's a location in space. So you take space here, and between my fingers there's a point. I take that away. That location, that's a point. It doesn't have a size to it, but I can identify that point by where it is in space. Line. A line is a straight arrangement of points. A straight arrangement of points. There are infinitely many points in a line. Because points don't have any size, you know, and within a 1 inch you could fit an infinite number of points. But as long as they're in a straight arrangement. So a line is named by using two points on the line. So for example, 2 points on this line are A, B. Okay? And then you put arrows on the end of the line to show that it keeps going in both directions. Right? If not, then it would just be a line segment. A lot of people confuse line segment and line. A line keeps going in both directions. So we call this line AB or line BA. And so we have AB or BA. That's how I'd like for you to name it. Rather than write line in front of the letters, use a symbol, a segment with arrows on it above the two letters to name the line. The order of the letters when you name a line does not matter. Okay? Order of the letters does not matter. Everybody have it? All right. Looks like a few of you are still writing. I'll wait. All right. Plane. A plane can somebody name a plane in this room? Tell me what represents a plane in this room? Okay, your desktop is a plane. It's part of a plane because a plane extends forever in all directions. But the desktop is a plane. The chalkboard is a plane. The ceiling's a plane. Okay, any flat surface that extends out is a plane. So a plane has length and width, but no thickness. Is a flat surface that extends forever. You name a plane by using 3 points in the plane or a capital cursive letter. So this plane, again, 3 points make a plane. 2 points make a line, 3 points make a plane. So we've got 3 points here. We've got C, D, and E. So this is plane CDE. Another way, more commonly, planes are named with a capital cursive letter. So it may have like a cursive letter P in it. So that would be plane P. Okay. Any questions on what a plane is or naming a plane? No questions. Okay. Next term, space. Space is the set of all points. The set of all points. Space. Postulates. Postulates are statements that we assume to be true. They establish some first principles upon which geometry is based. And as I told you, Euclid is the ancient Greek mathematician that established geometry's first postulates. So postulates are not proven. They're just something that we assume that they're true. And then we use them as rules for geometry. A postulate that has been proven, we can call it a theorem. Theorems are results that we deduce. Deduction is a type of logic. Results that we deduce from undefined terms, definition or postulates, and or results that follow from them. All right? Those are theorems. It's something that can be proven. So that's a good test question. True, false, or multiple choice. Knowing the difference between a postulate and a theorem. Postulate 2.1. Every line contains at least two distinct points. So we've got line AB here, and then again I name line AB by, I put AB, the letters AB with a line symbol over it, or BA with a line symbol over it. Everybody have it? Okay. Postulate 2.2. Two points are contained in one and only one line. All right, so if you have 2 points, there's only one line that goes through both those points. You can illustrate that by, we have the line AB here, right? Anything else that goes through AB is going to be curved. Postulate 2.3. If 2 points are in a plane, then the line containing these points is also in the plane. So if A, B are in a plane, then the line that goes through A and B will also be in that plane. Any questions on those postulates? Okay. Points are said to be collinear if there is a line containing all of the points. So points are collinear if there's a line containing all the points. They are non-collinear if there is no line that contains all of the points. So we can take an example. We take this line, we would say A, B, and C are collinear. Then we add this point D. D is not on the line. So now those 4 points, we would say A, B, C, and D are non-collinear. Or A, B, and D are non-collinear. Everybody have it? All right. Three non-collinear points are contained in one and only one plane. Three non-collinear points are contained in one and only one plane, and every plane contains at least 3 non-collinear points. So 3 points make a plane. The points are called coplanar . Points are called coplanar if there's a plane containing all of the points. In space, there exists at least 4 points that are not all coplanar. So we have A, B, and C are coplanar, and then I take this fourth point. Okay, there's going to be, you know, a fourth point. If I take a fourth point, it could be on the plane, but if it's not, right, then they're non-coplanar. If it's just 3 points, then they're going to be coplanar. But once I add that fourth point, then it's possible they're non-coplanar. Yes?
If a plane extends in every direction, how can it not be in the plane?
It doesn't extend in that. It extends lengthwise and widthwise. Okay, it doesn't extend in all directions. That's space. That's our next term. But this, you know, it's like this desktop. You know, this desktop is a plane, and I've got 1, 2, 3 points on that. But then I take this rock, right? The rock is my fourth point. It's not part of the desktop, is it? It's not in that plane. Definition. Oh, we already defined space up at the top. Yeah. So the definition here is coordinate. The real number associated with a point on a number line is a coordinate. So we've got -2, -1, 0, 1, 2, and 3, right? And so the coordinate for point A is -1. It's the number associated with point A. Line segment. A line segment consists of 2 points called the end points of the segment and all the points between them that are collinear with the 2 points. So a line segment looks like this. We've got the 2 endpoints, A and B, and all the points in between them. This is, a lot of people call this a line. Okay, this is a line segment in our class. Now, when I name a line segment, again, the order of the letters doesn't matter. I'm going to put a segment symbol above. So now I don't put arrows on the end of it. I just draw a dash above AB and BA. That's how I name the line segment. Now, if I'm talking about the distance of the line segment, then I don't put a symbol above AB. When I just have the letters, that means it's the length. Or you could put M of AB with the symbol AB above it. That means the measure of segment AB. That means distance. All right, Kyler. So we're taking notes here. The notes will be posted on Canvas. I'm doing a video of it right now. What goes on the screen, you can get the notes off of Canvas, off the link. Here's the syllabus. Read this. Have your parent read it. Sign it. Turn it in. Bottom half of the page That's 3 points. Homework. This is your homework. Okay? All right. Thank you. Two segments are said to be congruent if they have the same length. So we've got segment AB and segment CD. Right? If I measure them and they have the same length, then to show, so AB equals CD, that's saying the two lengths are equal. To show that they're the same length or that they are congruent, I use tick marks. I'll put the same number of tick marks on the segment. That symbolizes, that tick mark shows that those two lines are the same length. Can be any number of tick marks as long as it's the same. Maybe somewhere else on the page I had marked two lines congruent with a single tick mark, so I would want to use two tick marks here. Doesn't matter how many tick marks, as long as the tick marks are the same number, that means we have congruent segments. Everybody have it? All right. Array. Array is a portion of a line that has one endpoint and extends indefinitely in one direction. Okay, so it's named AB with a ray symbol over it. Now, on array, this is ray AB. The order of the letters matters. The first letter is your endpoint. Has to be your endpoint. This is ray AB. Okay? If I say ray BA, okay, ray BA is going the other direction, right? Now in your symbol always is going to go pointing to the right, but this is ray BA, and up above is ray AB. Everybody see the difference? So the order of the letters matters on array. Angle. Two line segments or rays meeting at a common endpoint is an angle. The endpoint is called the vertex of the angle, and the segments or rays are called the side of the angle. So this is angle, I would name this angle ABC. The vertex, okay, and this is important because a lot of people don't get this down, and then they miss points because They don't name angles correctly. The vertex B has to be the middle letter when you name the angle. Okay? The vertex has to be in the middle. Now I could also name this angle CBA. It's the same angle as long as B is a vertex. Now, if there's only two segments that intersect B, I can name this angle with one letter. I could just call this angle B. But if I had another line coming from B, there's more than one possible angle there. Anytime at a vertex there's more than one possible angle that could be named, you have to use three letters. If it's just one possible angle, like here, you know, we're not talking about angles greater than 180, anything less than a line, then you can name it with one letter. Make sure you know that the vertex is the middle letter. Any questions? Okay, so I'm going to draw a picture here of the parts of an angle. So we take this angle D, E, F, right? So the vertex is point E, and the sides are the sides of the angle. All right. Any questions there? All right. Now we're going to use this figure here, and we're going to name some angles. Okay, so go ahead and take a minute here. Let's start out. We'll name them all with three letters. So name all the possible angles in this figure with three letters. All right, so let's list them. Somebody give me one of the angles. Angle what? Just call them out. Anybody? TAH. That's one angle. Okay, so we've got TAH. That's there. What other angles? Say again? HAM. HAM would be here. Okay. Give me another angle. Angle MAT is one. Is there? Okay, give me another one. Say again. Angle HMA. There's one. That's here. Okay. Any more? There's one more. MHA. Angle MHA. Okay, so those are all the angles in the figure. Now, which of these angles can I name with just one letter? Which ones can I name? Yes, give me one. HAT. No, I mean I couldn't name that with angle A because if I just call this angle A, then there's other possible angles there. There's this angle, and there's this angle. There's three possible angles at A. Give me. HMA is one. Yes, I could call HMA angle M. Right? And MHA is the other one. What could I call it? What could I call that angle? Angle H or angle H. All right. Any questions? No questions. Okay, we'll stop there.